Hello dear students, welcome to a new math session. In this session we'll be talking about the non-negative integer power. Let's start. Let's start by some rules. The first one, if a to the power of n is multiplied to the power of n, if you have two numbers that are having the same base multiplied together, the result is the base as it is, and then we add the powers. So the result is a to the power of m plus n. Same thing, if you're dividing two numbers having the same base, like a to the power of m divided by a to the power of n, the result is a to the power of m minus n. So when we divide, we do not change the base and we subtract the power. And also in the multiplication, when we multiply, we do not change the base and we add the power. Rule number 3, a to the power of n all to the power of m equals a to the power of m times n. If the power is standing on a shoulder of another power, we multiply the powers. So a to the power of m all to the power of n equals a to the power of m times n. Rule number 4, ab all to the power of m equals a to the power of m, b to the power of m. If you have two terms multiplied together and they both have a power of m, then this power of m will go on each of them, like a to the power of m, b to the power of m. Rule number 5, the same thing applied on the multiplication will be also applied on the division. If you have a over b all to the power of n, then it will be a to the power of n divided by b to the power of n. As we said in the previous session, that if negative a over b has a power of n and n is an even number, then the even eats the negative. So it will be a over b all to the power of n. If we have negative a over b to the power of n, where n is an odd number, then the negative remains as it is. So it would be negative, then a over b all to the power of n. Anything to the power of 0, like in this fraction, a over b to the power of 0, the result is always 1. Anything to the power of 0, the result is always 1. But in this case, a cannot be 0 and b cannot be 0. Let's now move to exercise number 1. Find the result of each of the following. Question number 1. 1 over 5 to the power of 3 multiplied by 1 over 5 to the power of 2. The base here in both fractions is 1 over 5. So if you have them having the same base, we can easily combine the powers. So it will be 1 over 5. If you multiply, we add the powers. So it's 1 over 5 to the power of 3 plus 2, which is 1 over 5 to the power of 5. Question 2. 3 over 4 to the power of 3 multiplied by 3 over 4 to the power of 5. Same base, I can combine the powers. So it will be 3 over 4, and then when we multiply, we add the power. 3 plus 5, it is 8. Then 3 over 4 to the power of 8. In question 3, you can see that the two bases are different. One of them is 3 over 5 and the other one is negative 3 over 5. Actually, they are not different because in the second one, we can put the negative outside so we can have it as the same base. Let's see how we're going to solve it. 3 over 5 to the power of 2 multiplied by negative and then 3 over 5 to the power of 3. The negative remains as it is, then 3 over 5 to the power of 2 plus 3, so the result is negative 3 over 5 all to the power of 5. In exercise number 2, it's the same idea of exercise number 1, but here we're doing division instead of multiplication. When we do division, we subtract the powers. But don't forget that we must have the same base. Question 1. We have here the same base. then it will be 1 over 3, and then we subtract the powers, 5 minus 2, so the result is 1 over 3 to the power of 3. Next one, they're having the same base, negative 2 over 5, all to the power of 6 minus 4, so it's negative 2 over 5, all to the power of 2. The even power eats the negative, so it will be 2 over 5 to the power of 2. If you want to simplify it more, it's 4 over 25. Question number 3, it's 3 over 7 to the power of 6 divided by negative 3 over 7 to the power of 3. So it will be negative 3 over 7 to the power of x minus 3. Then the result is negative 3 over 7 all to the power of 3. Exercise number 3, it's a mix between multiplying fractions with powers and also dividing fractions with powers. As you can see here, we have the same base, which is negative 3 over 7. Then, when we multiply, we add the powers. When we divide, we subtract the powers. So it will be to the power of 3 plus another power of 3 minus the power of 6. So it's negative 3 over 7 to the power of 0. As we said, anything to the power of 0 is equal to 1, except for 0 power 0, which is undefined. In question 2, we're going to change the mixed number into a fraction, and then when a power is on a shoulder of another power, we multiply the powers. So this one will be negative 5 over 2, all to the power of 6. 6 is an even power, it eats the negative, so it's 5 over 2, all to the power of 6. Question 3, it's negative half to the power of, we multiply the powers, so it's 2 times 4, then it's negative half to the power of 8. The even power eats the negative, so it's 1 over 2, all to the power of 8. Let's now move to exercise number 4. Exercise number 4 is a different idea where we have an expression, we have the values of each variable, and we want to find the value of the whole expression when we substitute the variables by their new values. In this one, we're going to substitute the x by half to the power of 2 multiplied by 2, which is the z, divided by negative 3 over 4, which is the y, all to the power of 2. So in this one, it's 1 over 4 multiplied by 2 divided by negative 3 over 4, all squared. So this one will be half divided by negative 3 over 4 to the power of 2. Keep change flip, so it's half times 4 over negative 3 all to the power of 2. Then it is, if you simplify what's inside, divided by 2, it's 2, divided by 2, it's 1. So it's negative 2 over 3 to the power of 2. The even power eats the negative, so it's 2 over 3 to the power of 2, which is 4 over 9. Let's now go to the evaluation part. Please, when you see the questions, try to answer the questions yourself, then play the video again to check your answer. Calculate each of the following, then put the result in the simplest form. So here we have the same base, it's 2 over 3 all to the power of 3 plus 2, which is 2 over 3 all to the power of 5, which is 32 divided by 243. That came from 2 to the power of 5 over 3 to the power of 5. Question B, it's negative 2 over 3 to the power of 3 multiplied by 2 over 3 to the power of 2, as long as we have the same base, so it's negative 2 over 3. We add the powers, 3 plus 2 will be 5. Then, like the previous one, it's negative 32, which came from 2 power 5, over 243 that came from 3 to the power of 5. Question C. If you have a mixed number, we do it into a fraction, so it's 5 over 2, all to the power of 6, as we have here the power on a shoulder of another power, we multiply the powers. Question D, it will be x to the power of 2 times 2 over y to the power of 3 times 2, which is x power 4 divided by y power 6. Question E, the even power eats the negative, so it's b power 4 over a power 2. Last question, question F. As we said in E, the even power eats the negative, so x to the power of 6 over y to the power of 4. By finishing the evaluation part, we came to the end of our session. Thank you very much and wishing you best of luck.